Mr. Prashant Chaturvedi. A graduate mechanical engineer, Mr. Prashant Chaturvedi has an overall experience of 24 years in the welding and cutting industry. He is the general manager with Mesa Cutting Systems and an authorized trainer on equipment safety. Mr. Prashant has personally conducted over 500 training sessions in different industry segments in the past 15 years. Today, he will be talking about MESSER, all thermal cutting technologies under one roof. So let's welcome Mr. Prashant.
Thank you so much. And welcome to this part. I mean, we have been now talking on the joining of different metals, but if you need to join them, there need to be two pieces, right? And to get the right two pieces, you need to cut them right. So I'm taking the cutting part of this. Gentlemen, I am Prashant. My short introduction has been given, so I will not take much of your time and straight away jump to the topic on different thermal cutting processes that you use in industry. A little bit about Messer. Messer is a family-owned company, and Mr. Stefan Messer is the present CEO and owner. It is based, the headquarters are based at Bansodan. This place is near Frankfurt. And primarily, they are also into the complete gas business. So it means that much of the businesses, almost 60% of the revenue of Mesa Cutting Systems comes from different industrial gases. And as well, they have different divisions, right from Spectron, which is a specialty gas equipment company, Mesa Cutting Systems, which is the primarily right from Oxy Fuel, plasma and laser cutting equipment, different medical gases, CO2 gases, and then there is a company which is BIT, which is into the instrumentation related to medical. So this is the bunch of the Mesa world, and their Mesa Cutting Systems, which we are today talking the topic on, is situated across the continents at 5 places. So you can just see on the screen that across the globe, Messer has its presence. These are the different strategically placed, the sales and service offices, again, across the globe. And if we just take it to India, our plant is based at Coimbatore, and I request the fellow participant, whosoever are close, anytime you happen to be in Coimbatore, do visit. This is not a very huge plant. It is in some 5 acres of land, but it is one of the very beautiful plants from Mesa Cutting System family. So it's almost like a German plant, but inside India. So I invite you, whenever you are in and around Coimbatore, do write to us and we would arrange a visit to our factory. Here we primarily manufacture the complete range of Oxy Fuel, plasma and laser machines. So if you take as a company, when you talk of different processes, these 3 processes come under one roof, and Messer is the only company where the complete plate cutting solutions are under one umbrella. We'll just go through that quickly. And what is the portfolio that we offer you as of now? What services we are giving in India? A quick glimpse. We are market leaders as far as the range of the laser cutting machines. And then we have a complete range of gas equipments. Actually, Messer's origin started with a development of the acetylene torch, which was invented almost 100 gas equipments that we generally see: cutting torches, regulators, flashback arresters, the machine torches, and the range of equipment is to the gas series. When we are talking of different industrial processes, safety associated with these gases. So we do a complete engineered gas supply system. Equipments imported from, maybe from China or something, and you're not happy with them, they can be upgraded, and we can use in industry. So right when we call them thin sheets or foils, then it is right from 0.1 mm to 6 mm. We generally term that into the family of sheets and foils. Then we see plates around in the factories, right? So these are, from 6 mm to 50 mm thicknesses. When they are there, we call them plates. These are all under the family of flats. But when you go beyond 50 mm, then generally these are thick plates. And then you go beyond 100 mm, people start calling them slabs. So right from 300 mm slab to a very thin foil of 0.1 mm, 0.2 mm, engineering industry uses them all. And to use them, you need to cut them into various sizes and shapes. Right. So we will be discussing the complete solution. I know I'm running out of time, so I will make a little bit of, sort of a quick run through the presentation, and then you can visit our website, you can visit our YouTube channel, and you can go to our LinkedIn page, and there will be whole lot of good videos that you can run around to understand the topics in length. Right. So when we talk of mechanical processes, these processes, the basic router cutting, the cutting, these are very accurate, whereas there is absolutely no heat, but the processes are costly as well as slow. And when we talk of the three basic processes of Oxy Fuel cutting, means we use oxygen and fuel gas. This fuel can be acetylene or LPG or BMCG. Generally, these are the three fuel gases that we use. And then we have the famous plasma technology, where we use a plasma power source to use this heat of plasma as our cutting, heat source. And the latest one, the buzzword that the whole industry talks of, is laser cutting. In laser, our power source or our source of heat comes from a laser power source. So when we talk of Oxy Fuel, plasma and laser, in fact, the earliest process was Oxy Fuel, then plasma and laser came around. But still, none has totally replaced the other one. All three processes equally exist into our engineering world, and all three have their own space. That's the beauty of them. Nothing has replaced it totally. So as you know, during welding, you need to prepare different types of joint. So while the cutting process itself, you can use the beveling tools now and reduce your post-cut operations of preparing the joints, the weld joints. So if a right tool is used, you can straight away cut the plate into, the K, Y, or X, and then a small finishing can give you a weld ready plate. The three processes generally people get confused of how do I use. So these are actually covered by a bubble diagram, and which shows that these three processes can be used in different. So when your precision increases, the process changes. At the same time, your thickness increases, the process changes. A bigger area, higher thickness area with low precision is still covered by the Oxy Fuel process. And you see there are also overlap areas. So there are certain areas that you can choose between the two processes, looking at your different conditions. It is not that one process is faster than other. At times you will have to make a judgment looking at your productivity as well as looking at your finish requirement and looking at the thickness that you are going to do. So what plate you are going to cut, what metal you are going to cut, what thickness you are going to cut, what is your finish requirement, that all together would decide which process you are going to use. Because that's a very complex matrix in terms of selection of these processes. Laser would have the least running cost, but at the same time, it has a heavy investment. A laser cutting machine would cost much higher, maybe 3 times, 4 times, to a Oxy Fuel cutting machine. But Oxy Fuel process would require continuous consumption of the gases, acetylene, oxygen, or something. And similarly, plasma process can be the fastest process, but at the same time, it would also have the consumable involved. So you have to make a holistic approach in terms of your application, where our team of application engineer can actually help you to select the right process for your job requirement. And that's the beauty of having all the three processes in one under one roof, that we give the open chart to our client and help him through the selection process, that what process is actually required for his particular application. Because if we are only from laser, we will pitch in only for laser. But for us, all three options are open. So we discuss and decide, our application department, with the customer, that this looks to be the finest process in terms of the quality requirement from you, and also in terms of your productivity requirement, right? So Oxy Fuel process, how much time do I have? So another 5 minutes?
Yeah, you have by 5:10 you can probably
sir,
you can
sir,
consider 5:10.
you have another 5 minutes. Yes, correct.
Yeah.
No problem. Thank you. I'll try to give the gist of everything very quickly. And I'm also joined by my colleague, Mr. Utkarsh Landekar. So if there are questions on applications, so I have an application expert along with me as well, that we take together. Now you see the Oxy Fuel process. Cutting torch into an industry, maybe a roadside welder also, or a cutter, you must have seen using a cutting torch, or you must have seen a very high precision machine using an Oxy Fuel process. The principle of process remains the same. Generally, we feel that, you know, the flame has actually done the cutting, but the flame that you see in an Oxy Fuel system is only for heating application. It's the cutting oxygen which actually does the cutting work. So this cutting oxygen gives a high stream, a high pressure stream of oxygen that actually oxidizes the surface, which melts in, and when by maneuvering of your torch, you get a cut through a plate. So higher thicknesses are predominantly cut by Oxy Fuel process. And into that as well, selection between acetylene and LPG, or LPG's another form is BMCG, that is promoted by Bharat Petroleum. So higher the thicknesses you go, for longer flames, you need to necessarily go with LPG or BMCG, which we term as a slow burning gas. So this is the principle of Oxy Fuel cutting. And in Oxy Fuel cutting, you have these features of lowest cutting cost per mm thickness, but at the same time, you can even operate 10 torches. You see the diagram, the picture on the other side, you can use multiple torches on the same gantry and your productivity can be enhanced. Up to 300 mm cutting, you can do very well with this. So the cost involved are electricity for running the machine and fuel. These are the two major costs. And the consumables are very less and not much costly as far as the Oxy Fuel process is considered. When you go with the plasma process into Oxy Fuel, this torch that you see is a patented Messer torch. It has an auto height sensing. At the same time, it has an auto ignition. And the curve width out of this torch is one of the most beautiful. This is an alpha torch that we call as. So sometimes the look is so beautiful that people mistake it as a plasma torch, but this is an Oxy Fuel self-igniting and auto height sensing torch. Then you know the plasma process, which is the most common and predominantly used into cutting now. Much sections of the cutting are happening by the plasma. Here you need a plasma source, which you create between an electrode and a nozzle. You create by high voltage, you create ionize the gas between these two, which we call as the plasma gas. And this ionized gas, which forms a high stream of energy, you focus it and you get a plasma. But these nozzles and the electrodes are consumable here. You have to select the right nozzle and consumable to give you the best quality of life. But the cutting speeds can be much higher. Right? Now, again, similarly here, the cost of is totally divided. The feature is low cutting cost per thickness, again between 6 mm to 32 mm. Then you can work 2 torches simultaneously. Up to 150 mm, you can go very well with that. In this also, there are then oxygen cutting, oxygen plasma that we call, and now a new series of high definition plasma. So there is a complete high definition series which is available. We have a complete range of plasma cutting machines. We are, with a lot of humility, we are the market leaders in that, and you will get the best quality machines from Mesa. We use either hypertherm power sources, as laser. I would quickly run through this. You all know the laser principle is the principle is the same that we used to, play in our childhood with one lens, and we would go in the sun and burn a little piece of paper. The same principle, when multiplied, 1,000 times, actually brings into the laser system to us. So it has a laser power source. You use the light energy, focus it, almost to a pinpoint where it can cut through all metals, right? So these are but hazardous things. These are we have a complete range, right from the entry-level machine, then into a complete encapsulated machine, generally nomenclated into kilowatts. So higher kilowatts are now available in industry. It starts from 0.5 kilowatt, but now generally people would go with 1 kilowatt machine, and then the range can go up to as high as 10 kilowatt very easily. But combo which is available from the house of Messer. I'm just running 1 or 2 slides more, and then I come to the end of the presentation. As my colleague Nimesh has already explained on the welding side, similarly, all these options are also available now. ERP Connect, the software on the nesting, the software OmniWay, and then you can even capture the complete information about how your machine was running, how much time the machine, there was the actually arc on the machine in terms of, our machine, how much time the plasma arc was running. So what was the ideal time of the machine, how much cutting it has done. So complete data is available. So it's completely, IoT enabled, and you can go for these options as well, where you can remotely, even on your mobile, keep checking how is your cutting work being done in your industry, in your factory, in your plant. And just to the last slide, that when we are talking of lot of structural requirements, that the level of fabrication that we need to do, or something like, the level of bridges that we need to make, these type of applications require some components where you are having thick plates, 30 and above plates. At the same time, you need to cut them in contours, but you also need, drilled hole on them, certain tappings on them, so that they can be very quickly assembled on the site. For such very special requirement, where one plate you need to have multiple operations to be done, there are some unique solution machines also available, like that we have Plamill, where you can, apart from doing the plasma cutting, you can even do the drilling, tapping, milling, marking operations on the same machine. That means these heavy components need not be carried on different machine, and the one machine itself can be used, and a complete component can just be out of your plant, primarily used by a lot of bridge manufacturing areas, right? So this is a combination where cutting and the mechanical processes of milling, tapping, drilling can be done. We already have 2 installations of this. These are on a higher side, higher capital incentive machines. Already 2 machines are established, primarily for railway.
Sorry,
I'm done. Yeah, don't worry. Right. So with that, I thank you all for this opportunity. Thanks for sharing this stage. Do write to us, visit our YouTube channel for a lot of videos. I did not use the videos because they generally don't go along very well in this virtual platforms. And thank you for all your time.